Welcome back, folks, to AI and Entrepreneurship in Practice. So what is this learning journey actually about? Given our real-world project structure, it's now time to talk about business and data understanding. And the methodology we use for that is called CRISP-DM. So why are we talking about business and data understanding? If you look in practice, on practical examples, you will see that a lot of proof of concepts and data science projects actually failed. They never went to production. Can you imagine why and how? And what's the size, the percentage size of those projects never ending up in production? Yes, somehow, right? It's estimated on given data that more than 85% of those projects never actually enter and fail to go into production. So what is the reason for that? You may have some kind of aspects, some kind of ideas to that. It's actually quite diverse. It ranges from, undefined tasks, from communications aspects, data, skills, quality, setup, timelines, the plethora actually of reasons, right? Why these kinds of initiatives, maybe also these ideas that you have to think, how can we prototype them, fail. So how do we prevent those kinds of aspects? What can we do systematically in order to increase the probability that your idea never ends up at the proof of concept fail? There's a tooling for that, and this tooling, this method is called CRISP-DM, a cross-industry standard for a process for data mining, CRISP-DM. And it's one of the levers actually to mitigate this risk of. So what is this process about? Actually pretty easy. Different steps to consider, and in each step you need to ask a couple of questions throughout the piloting phase. First starts business understanding. Why are we doing that? Why are we doing the project? Who are our users? Who are actually our stakeholders in there? Second comes data understanding. What kind of data do we need actually to build a solution, for instance? Third one, data preparation, right? How do we get the data? How do we acquire the data? How do we maybe turn the data in something that is consumable, is processable, right? And once we have it in the shape, what kind of modeling architecture are we using, right? What kind of machine learning module maybe we use? Fourth is the evaluation. How do we test the solution? Do we have users? Can we collect somehow feedback from users of these solutions? And last but not least, how do we deploy that? What is needed? What kind of requirements are set in scaling your solutions? And that's a continuous loop, obviously, which you need to consider throughout while moving and iterating over your technical implements about your interaction with the data, but also starting with interacting with your clients and testing and getting feedback done. So it's in practice, right, this session. So let's draw a couple of examples. We brought 3 different examples for you today in order to guide you through, of existing real-world cases where we applied the CRISP-DM flow in order to challenge and improve our solution. Application number 1, healthcare, a remote condition monitoring for medical devices. So here we worked together with a client, a MedTech client, actually a multinational champion, and that, which produces dialysis machines. So these are machines standing in the home, and the company asked, can we apply condition monitoring to these machines? Can we enter the world of IoT and data? Kind of interesting project, very awesome to work actually directly with the clients together. So we started with first the business understanding. So we thought, what is actually a challenge? What is the pain you actually have as a client? And it turned out that there are many of these devices, dialysis systems, right? They are at home equipped where blood flows through that, right? It's a critical infrastructure. And a lot of these devices are sent to the office, to the company back, because the patients, the clients at home, thought they were somehow defect. And a lot of the testing, a lot of these defects were actually not true. They're just very noisy, right? And this noisy made the actual patient think about, is that still okay? Is that maybe already a fault? Right? So there are different persona, and in the previous seminars and learning journeys, you learned about personas and learned about how important it is to walk in the customer's shoes. So we define different personas of, the stakeholders that we have. The patient who asks, why is the device so noisy? Am I still safe? The technical support is like, why are so many, patients complain about these devices? This is something really broken, right? The service maintainers are like, hey, it's actually okay. It's just fine. Why are they returning? And the business analyst, why do we have such a capital expenses, right? And refurbished costs. So there are different personas in your solution, which you may think is only the patient, but there's a bit more. So look left to the right to the process, and you will identify these personas, right? So lessons learned, all stakeholders need to be involved from the beginning on. Don't only focus on one persona, focus on multiple personas that will be always involved. Second aspect, data understanding. So traditionally I would say, okay, if it's noisy, why not equipping a sensor which captures the sound and then maybe analyzes, right? Similar as you maybe have for cars. But you as a patient, do you want to have actually an audio, a microphone attached to your devices? Maybe an Alexa, right? But not automatic devices. So that means on data understanding, it's also clear that you need to consider other aspects, not only whether it's doable for and viable for the technical solution, but also with regards, acceptable for your customers, for your clients, for your personas, right? In which privacy concerns are of serious matter. And this drawed for us, focusing on the right data. And the right data in this case was then not sound data, but also and actually vibration data, which may be the indicator for, whether something is corrupt or not. So let's collect vibration data. Once the data understanding is done, we are tackling towards the data processing. Data processing means, given the first samples of data, you collect it on a certain kind of, set of experimental devices, the first data, then the labeling starts. So we need to differentiate in a machine learning perspective between a healthy state and a non-healthy state. And this needs to be somehow correctly labeled, right? And it's not like in the consumer tag where cats and dogs can be, but sometimes this kinds of data is pretty tough to label, and you need to include also the domain experts and the domain know-how of your client in order to identify what's the leading signals, what data makes sense and what not. So data augmentation, data labeling, these kinds of tasks are very effectively and very much needed in order to deal with the data processing effectively. Fourth, modeling, the fun part. Mostly only 10% of your project, to be frankly fair, right? Building models. So you start building a first experimental setup, but how do you define an objective function? So is it norm behavior? Is it outlier? Is it a classification task? Is it a forecasting system? Though these kinds of questions you need to ask to your prototype in order to identify, okay, we want to classify certain aspects. We want to maybe build an ensemble of different models in order to classify the certain objective function, right? In our case, random forests made quite a big and good move in this case, which also need to be embedded on the software sensor side. So comparing and baselining, with simple techniques in first place is the best practices when you start. Don't start with the most crazy model. Start with baselining and incrementally improve over data engineering and modeling aspects. Then the end user, right? Don't forget about the end user. So testing means also testing it in the real world cases, right? Most experimental are being done in a synthesized data set. So you have your train, you have your benchmark, you improve your models, but never compare, only synthesized data sets in your models, but actually design for real world testing, because data outside of your experimental setup will always be different than data that is within your experimental setup. That means, you need to adjust the data, you need to adjust the modeling, and feasibility tests need to happen end-to-end as soon as possible to get feedback from real-world data. So prediction needs to be done on new data sets. Last but not least, deployment and scale, right? And here it comes also again back to the personas. Once you have a solution that is usable, that has some kinds of user experience, then you need to identify which capability, which insight, which demonstration needs to be accessible to which persona. The patient maybe needs a different part of explainability and condition monitoring than the technical support. And the technical support maybe needs a different dashboard than the failure analysis, right? So therefore, the end application, look, feel, user experience, user design, right, is of importance. Any high-stake given machine learning module is worth nothing without a great user experience that one can use your model, your insight that has been done. This was one-time loop actually through the CRISP-DM model and methodology, spawning from business understanding, data preparation, modeling, evaluation, and deployment, and is highly applicable to all kinds of use cases, which you maybe also to your. So let's give it a shot. In the next learning journey, we'll look at an energy case. So keep on going.